Okay, we're going to talk about Chapter 13, and Chapter 13 deals with non-parametric statistics. We're just going to show you some examples as we go through here. We're not going to have the fancy tests like we had before with the z-test and all these other tests. We're going to have some very simple tests to look at. The advantage of these are the advantage of non-parametric methods have over parametric methods. They can be used to test the population parameters when the variable is not normally distributed. They can be used when data is nominal or ordinal, and they can be used to test hypotheses that does not involve population parameters. And in most cases, the computations are easier than those of parametric, and they are easier to understand. And the disadvantages are they are less sensitive, they tend to use less information, and they're less efficient. Since there are both advantages and disadvantages to non-parametric methods, the researchers should use caution in selecting these methods. If the parametric assumptions can be met, the parametric methods are preferred. Many of the non-parametric tests involve the ranking of data, that is, the position of data arrayed according to some rating scale. Ranking is an ordinal variable. For example, suppose a judge decides to rate 5 speakers on an ascending scale of 1 to 10, with 1 being the best and 10 being the worst. For the categories such as voice, gestures, presentation, and platform personality, the ratings are shown in the chart. So you have A, B, C, D, E, the rating going through it. The rankings are next shown. E got the best ranking, so on outline. Since speaker E received the lowest score, 1 point, he or she is ranked first, speaker D is ranked second, 3 points, he or she is ranked second. Okay, one of the simplest non-parametric tests that we can use is the sign test. The test value is the smallest number of plus or minus signs. So we're going to look at some of these. For example, there are 8 positive signs and 3 negative signs. The test value is 3. When the sample size is 25 or less, table J and appendix C is used to determine the critical value for a specific alpha. If the test value is less than or equal to that critical value obtained for the table, the null hypothesis should be rejected. The values in table J are obtained from a binomial distribution. A convenience store owner hypothesizes that the median number of snow cones he shears sells per day is 40. A random sample of 20 days yields the following data for the number of snow cones sold each day. At point 05, test hypotheses. So let's see here. Okay, let's look at this here. How many? 40. How many are below or above? So what's going here? This one's minus. Let's do a tally mark here. Pluses and minus. So we're going to go minus plus going across the top. That's a 0. Less than, less than, less than, less than. So therefore we have 15 negatives. So because the convenience store owner recognizes, hypothesizes the number of medium snow cones that sells per day is 40. And we went through and tested the values, and we came up with 15 minuses and 3 plus. Our null hypotheses on here would be the median equals 40. And our alternate and I'm just going to abbreviate median does not equal 40. And the claim is it equals 40. We found our plus and negative signs. Now if we go in the back of the book, table J, to get our critical value, table J, critical value, we're using 0.05 to tell n equals 0.05, and 18, we end up with 4. Now where is our 18 here? If we look in here, we have 4, 8, 16. Going through here, for example, if we look back at this example, there are 8 positive and 3 negative. The test value is 3. When the sample size is 25 less, we use table A, the critical value, and the test value is less than or equal to the critical value. Now if we look at this critical value here at table J, using 18 as the number of values, because we had 3 zeros here, because you can count this 4, 8, 12, 16, 17, 18, 19, 20, and then we have 2 zeros in there, so we have 18 values. The critical value was 4. Alright, here, the critical value is 4. The test value was 3. Since 3 is less than 4, we would not, test value is less than or equal to 4, then the null hypothesis is rejected, and we say, summarize results, there is enough evidence to reject the claim that the median number of snow cones is 40. So the claim was 40, and we're rejecting that claim, because our test value, which is 3, is less than our critical value of 4, using this test. When the sample size is 26 or more, the normal approximation can be used to test the value. The formula is given, the critical value is found in table E. So then we use it. If it's more than 26, we use the Z table. Now the paired sign test. Now the paired sign test, the sign test can be also used to test sample means in a comparison of 2 dependent samples, such as before and after test. Recall that when dependent samples are taken from normally distributed populations, the t-test is used, and this is section 9.5. When conditions of normality cannot be met, the non-parametric sign test can be used. So, okay, here we go. A medical researcher believes that the number of ear infections in swimmers can be reduced as swimmers use earplugs. A sample of 10 people was selected, and the number of infections in a 4-month period was recorded. For the first 2 months, the swimmers did not use earplugs. During the second 2 months, they did. At the beginning of the second 2 months, each swimmer was examined to make sure no infections were present. The data is shown at alpha 0.05. Can the researcher conclude that using earplugs reduced the number of infections? So after, before, and after, it reduced the number of infections. So our null hypothesis here, I'm just going to state it here. Our null hypothesis is that the number of ear infections will not be reduced. The alternate is the number of ear infections will be reduced. For the critical value, we have to find the critical value now. Subtract each of the values from x after before and indicate the difference by a positive or negative sign or a 0 according to the value of the table. So x after, we had 2 before 0, so this is a plus. Well, actually, sorry, this 1 minus this 3 minus 2 is 1. This is a negative. 5 minus 4 is a positive. 4 minus 4 is 0 is positive. 2 minus 1 is positive. 4 minus 3 is positive. 3 minus 1 is positive. 5 minus 3 is positive. 2 minus 2 is 0. 1 minus 3 is negative. So you notice we have 2 negatives, 3 positives as we go through here. So now we have to go from table J, degrees of freedom here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 values. We're looking at 0.05. Table J, 9, 5, 9 degrees of freedom. It says we are going to come up with a test value. The 0 is not counted. So at most one negative sign is needed to reject the null hypotheses at 0.05. So our test value on here is going to be 1. Our critical value here, we went through. Compare the test value, count the number of positive and negative signs found in step 2. Use the smaller of 2, so the smaller of the 2 here is going to be 2 negative signs. Now we have to make the decision. There are 2 negative signs. The decision is not to reject the null hypotheses because 2 is not smaller than 1. And therefore, summarize results. There is not enough evidence to support the claim that the use of earplugs reduced the number of infections. So use of earplugs was our alternate hypothesis, and there is not enough evidence to reject that claim as we go through here. So that finishes up. Let me just talk one more little bit here. When conducting a one-tailed sign test, the researcher must scrutinize the data to determine whether they support the null hypothesis. If the data support the null hypothesis, there's no need to conduct the test. So, as in ear infections, on the other hand, if the number of ear infections were reduced, the most part would be larger than X of A values and would most be positive. Hence, the researcher would continue the procedure. A word of caution is in order. Little reasoning is required when we do these problems. When the sample size is 26 or more, the normal approximation can be used. So, as we go through here, the one sign test for single paired samples. State the hypotheses, identify the claim. Find the critical values for the single sign pair test. Compare each value with the conjecture median. If the value is larger than the conjecture median, replace it with a positive sign. If it is smaller than the conjecture median, replace it with a negative sign. Compute the test value, count the number of positive and negative signs found in step 2, and use the smaller value for your test value. Make the decision. Compare the test value with the critical value, table J. If the test value is less than or equal to the critical value, reject the null hypotheses. Summarize results. Note if the sample size is 26 or more, use table E for the following problem. So if we looked at another one and followed this procedure, the athletic director suggests that the median number of paid attendance at 20 local football games is 3,000. The data for sample is shown at alpha 0.05. Is there enough evidence to reject the claim? If we were printing the programs for the games, would you use figure this as a guide? So first of all, there are null hypotheses. Median equals, I'm going to put it below here, 3,000. And I'm going to put a big C for that's my claim. Alternate median does not equal 3,000. So let's do our plus or minus. We're looking at 3,000. So I'm just going to go here and do our tallies again. And put pluses here, minuses here. So we got 1. So we have 10 and 10. So we have 10 positives and 10 negatives. Now how many values we have here? We have 4 times 5, so we have 20 values. Table J in the back of the book. So if we look at table J in the back of the book, at 0.05, I believe it was, 0.05, table J with 18 degrees of freedom, we should have 4. 4 is our critical value. So 4 is our critical value. Our test value here, our test value is 10. Doesn't matter which one you use. And since 10 is not less than or equal to 4, we do not reject the null hypotheses. And we would say the median is approximately 3,000. And it says, if you were printing the programs for the games, would you use this figure as a guide? And I'd say yes. I'll use that figure as a guide because 3,000 would be a pretty good number to work with. So let's stop there and save that video first.